Leo de Moura. And I'll just say one thing, of course, if it weren't for Leo, we wouldn't all be here today. So I'm very grateful for him, and I'm very grateful to hear him speak. I remember 8 years ago when I started playing around with Lean just on my own for the first time. I was just looking through the code base, and I saw an inductive predicate for the first time, and it was just less than or equal to. And this, I had such a hard time understanding it at the time, and it's just kind of a pleasure to see how far the language has come, the library has come, and all of the great things that have been happening as a result. So, Leo, please take it away.
Thank you very much. I mean, very happy to be here. Thank you, everybody, uh, uh, for your love for Lean. And we're trying to push as hard as possible to make Lean even better, right? Lean is an open source programming language and for systems. All the tooling is implemented in Lean. We are really proud of that. Lean is very extensible. Basically, everything the build system, documentation, authoring tool, Verso, the type checker, static framework, compiler, everything is implemented in Lean. Lean has a small trusted kernel, right? The proofs can be exported and you can check with independent kernels, right? More about that today, later today. Uh, there were many really cool quotes in 2025 about Lean, but one we really liked at the Lean Flow was from Harry Goldenstein, saying that Lean is not just interesting to improver, but also well designed in modern programming language, right? Well, if we could go back in time and told ourselves what's happened in 2025, I think would not believe, right? There was so many good news last year, right? The numbers, we tried to collect some numbers, like we had 12 releases, we reached 19,000 unique installations. This is in the last 2 years only. These are unique. I mean, people, of course, many people install multiple times. More than 7,000 stars on GitHub, more than 50 courses that have been registered by the authors in the Lean community websites. We believe there are many more than that. Just last year, we had 4,000 PRs to the main repo, two major awards, and five startups using Lean, right? Plus, I mean, there are many more. I mean, these are the big ones. We had many things that are remarkable last year. DeepMind released the formal conjectures repo, two gold medal level performances by Harmonic and by Dance. That's the IMO. I think a few years ago, people thought it was even impossible to solve IMO problem, create a formal proof for them automatically. The Carlson theorem project has been completed. The AI AI math funds also a big deal, right? I mean, was great. Initially, it was $9 million fund, but they doubled because there were so many great proposals. 14 of them are using Lean. We are very happy with that. Velvet has been released in December. We have seen many other problems being solved by AI using Lean. Uh, the new websites, we know that in 2024, we tried, the community didn't like the websites. We tried again. And now I think we have a new website that the community likes and built on top of Verso, right? I mean, I think that's really cool. The ICARM Institute was launched last year. It's a big deal for the community, right? We have MathLib initiative that Johan told us about earlier today, but we also have the ICARM Institute and CSLib launched, right? It's another, I think, area where we're going to see lots happening in 2026. Lean got two major awards last year. One, the ACM SIGPLAN Programming Languages Software Awards, in recognition of the impact in programming languages research and practice. And the Scholar Awards was the first paper we had on Lean 10 years ago. I mean, this is a test of time award for the impact of the project. Funding was great. We're very, very grateful for the funding. Alex Gurko is funding the MathLib initiative and many developments that I will tell you more later today. That's improving the literacy programming, improving the user experience, right? It's great to have this kind of support. I think the MathLib initiative will have a huge impact, and the extra funding with this new project will also impact everybody that's using Lean for teaching, writing books. We even envision a future where people will write papers mixing Lean, LaTeX, and using Versa to author this kind of paper. We already hired the full team, right? We got the funding, people were skeptical, but we had an overwhelming number of applications and we have a really strong team behind this new effort. Uh, of course, all the good news I'm going to tell you today would not be possible without the LeanFlow team, right? And we have many of the people in these slides, but there are surprises people that are joining, like Wojtek, that's he develops the widget system for Lean 4, and he will be joining the flow in a few months, right? But I'm really grateful for the whole team at the flow, right? So all the progress we are seeing today would not be possible without the passionate work of all of them. Yeah, I'll try to give you some highlights, right? Some things that we delivered last year. Uh, One big news is the new module system. It will enable faster builds, right? I cannot imagine my life without the module system, right? For MathLib developers, maintainers, contributors, now you can change a proof and you do not have to compile all forwards dependencies of your file anymore. This is night and day. You can change doc strings without recompiling everything. It really improves the build times. And it's just the beginning, right? I mean, we just deployed the module system into MathLib. It will keep getting better and better. We are going to have better support for definitions too coming soon. Now also, we don't have to load the proofs by default. This has a huge impact on if you open the whole MathLib before this feature, it will take 6 GB of your machine. Now we get a 50% reduction. It's only 3 GB if you open the whole MathLib, right? And this is important, right? Many people, like especially newcomers, they don't know where things are stored in MathLib. They just say import MathLib. It's great. I mean, if you're learning, it's great. I do it myself all the time when I'm demoing MathLib. I just import the whole thing, and you can demo. You can demo. I mean, people can keep asking you things, and you don't have to remember what to import. Parallel elaboration. I thought this was in 2024, but no, this has been released in 2025. I mean, good things you take for granted and you cannot let them go away. And parallel elaboration is one of them, right? I love to see when you're using VS Code, see things, the orange bars. I don't know if orange is the color in your setup. In mine is orange. They move in parallel and recompiling everything. And on Tuesday, tomorrow, Sebastian will tell you more about the module system, how to take full advantage of the module system, and his future plans for it. We also deliver many performance improvements to MathLib. It keeps getting better and better. There is one I want to highlight today because it delivers a 9.7 reduction. But from this 9.7, 8.1 is due to external PR, a single PR by Jovan. I think he's here today. He was earlier today. But yeah, we're very many thanks to him. We are very grateful. I mean, I think the whole community benefits from this reduction, these performance improvements. Scalability, right? We're changing many parts of the system that do not affect all users, but affects many users. For example, being able to support large inductive data types. Some users love using large inductive data types. One example is the group by Tobias Grosser in the University of Cambridge. They have very large inductive data types, and now we have much better support for that. For match statements with huge writing match statements, and we will keep improving, right? We want to support all users. We finally deliver the new compiler, right? I mean, the previous one was the one that was implemented in 2018 for bootstrapping Lean 4, right? Most parts of Lean were implemented in Lean itself, but the compiler was one of them that was still C++. We started in 2022 to implement one in Lean in late 2022, but with the throw, the project was frozen and was only unfrozen in 2025, right? And we finally replaced it, right? And this change enabled many new optimizations, right? Not just optimizations, but also we managed to close many long-standing bug fixes. They're all marked as waiting for a new compiler, right? And we will have many more optimizations coming, right? And keep in mind, Lean is implemented in Lean. By improving the code generator, we optimize every single tool that has been built on top of Lean. And now, in the Lean code base, basically only the kernel and the runtime are implemented in C++. And this is by design, right? We don't want the kernel to be in Lean itself. You want it to be in a different language, the kernel we distribute with Lean. We will talk more about. I will tell you more about kernels later. But let me focus a little bit on proof automation. Last year we mentioned BV decide is this verified bit blasting, but Henrik kept improving it, and now it can solve 96% of all benchmarks in SMT-lib. SMT-lib is a repository of benchmarks, right? Coming from bug finding, software verification, hardware verification, you name it. And you have to keep in mind that the fastest solver can solve 99%, but it's not verified. It's not proof producing like BV decides. And 96% is really good, right? All key components are implemented and verified in Lean. And it's not just about the bit vectors. BV decides now supports all finite integer types. We support enumeration types, and you have structures that contains only the supported types. It will also be supported by BV decides. And it enables people that are many different application scenarios, these new features. We have also released Grind in 2025. You should view Grind as a piece of automation that's based on satisfiability
Then you can
modular
conclude here.
theories. Excuse me, my audio is bad. Can you
I
hear
think it
me?
was just some stray audio. You're okay. Keep going.
Okay. You can feel this over as imagine a whiteboard, right? Where you're putting facts that you are learning, like new equalities, inequalities, and you keep merging equalities into equivalence classes. It has congruence closure, matching modular equalities, constraint propagation, multiple engines like for arithmetic, commutative rings, associative and commutative operators. They all cooperate on this whiteboard. You're going to learn more about Grind and how to use it later this week. I think Kim's talk is on Friday or Thursday, but later this week, Kim will give a talk about Grinds, how tell you how to use it effectively, how to use the new annotations to take maximum advantage of Grinds. We use the following design principles, right? We want to support full dependence type theory, right? No translation to first order logic or higher order logic. We want a super fast startup time. You don't have to call external tool or download external dependency. It works out of the box. When it fails, we want to have diagnostics where we keep improving them, but we're already providing rich sets of information about the internal state of grinds. It should be extensible as everything we have in Lean, right? So you should be able to plug your own solvers, add your own normalizers, propagators, and so on. You don't need to have mathlib installed. Everything's configurable by type classes. Mathlib is pre-annotated, pre-configured to use grinds. This type class mechanism is what enables us to be able to use grind without mathlib. And the CSLib folks they tell me all the time that grinds is great for software verification. But if you look at mathlib today, there are almost 3,000 occurrences of grinds in mathlib. And we barely annotate as mathlib. It's a massive amount of work. Grind is like simp, right? You have to annotate your libraries. If they're not annotated, you don't get the maximum benefits. But it will happen, right? Tooling, right? Uh, well, many new features were released in 2025 for Lake, right? Remote caching, local artifact cache. This is funny because this feature request happens during JMM last year. We had a dinner during JMM at the beginning of 2025, and Alex Controvish and others were telling me about this issue. And now we have a local artifact cache. We have semantic versioning, multiple version workspaces, new targets, TOML support that many people in the industry like to have TOML support for their project configuration files. It's all now available in Lake. The language server is another one that is, for me, is impossible to imagine to live without all these features, right? For example, the auto-implicit inlays. I don't even remember life without this feature, right? Now you can see exactly the auto-implicits. We now have support for a no identifier. We have code actions for them. The go-to definition for type classes was a pain in the past, right? I mean, you want to go to the definition of the instance, not where the notation was defined as. And this is available now, right? The module hierarchy I use all the time when I'm refactoring my own codes. It's great to see all modules the hierarchy you import and the hierarchy that imports the module you are working on is super valuable. Also, information about the type information when you're writing an application, right? You know what the type of the next thing that's coming, right? This is also super valuable. The gutter declarations, yeah. Mark Huizinga has been keeping pushing the limits and making the user experience better and better. And we will keep doing that in 2026. Better error messages. I mean, error messages, they are an issue, right, for newcomers, and we are investing a lot on making them better, right? Uh, uh, we want the community to scale. We don't want new users to keep asking the same questions over and over again on Zulip, right? Some error messages, we selected one here that was really cryptic when you have this, is often due to meta variables, right? It doesn't mean anything for a newcomer. And the new error message is much better, right? Rob has been working on that, and will keep making it better and better, right? We want to get rid of all the horrible messages. We also now have mechanisms for people that's, for example, if someone's looking for results, that's how our accept is called in the Rust world, right? If some user that's familiar with Rust starts looking for a type called results, we'll tell you that it's called accept in Lean, right? Language, I mean, the stats library, we are almost delivering the stats library. When we started the flow, we had a vision of the components that we want to have in the stats library. We are almost there. In 2026, it's going to be complete, but in 2025, so many new features like iterators, async primitives, range slicers, verified containers like hash map, tree map, they're all verified. They come with a portfolio of lemmas. We also have growth that allows us to track library defects at scale. Marcus is going to tell you more about this, the stats library later this week and show that the stats library is really setting a standard for how a verified library should look like for people that care about writing verified software. And there are many new language features, right? We have now co-inductive predicates again. That was a feature that we had in Lean 3, but was lost in Lean 4. And now we have them, and they're way more powerful. Wojtek is going to tell you about co-inductive predicates on Thursday and tell you about you can even support mutual co-induction, right? And how you can use this new feature in your projects. Another big deal is MVC Gen is a framework for monadic verification. In the past, you would hear people would tell us, oh, the do notation is great, but it's horrible for if you want to prove anything about your program. MVCGen is our answer to that, but it's a framework that makes it way more convenient to prove things about code written using the do notation. And Sebastian Graf will tell you more tomorrow about MVCGen. We now also have partial fixed points, right? The partial keywords we all know, but you cannot prove anything about functions defined using partial. But partial fixed points, they are different, right? You can write possibly non-terminating functions using partial fixed points, but you can reason about this code, right? And function induction is another feature now. If you're using try question mark, it will suggest many times, and a powerful combo is function induction together with grinds, right? Websites. Yes, we have the new website. It was built using Verso. We are very happy. Sophia did a great job developing the new website using Verso. I think the design looks great. And we got a lot of positive feedback from the community, right? The Lean language reference manual now is way better, fully built on Verso, right? Uh, David Christiansen also ported to improving Lean and functional programming Lean to Verso, right? Another cool feature is that in your doc strings, you can reference the manuals. For example, I met a user that was telling me, "Oh, would be great to have a manual for grind." I said, "Well, the reference manual has a chapter. They did not know." And now in the doc string for grinds, we put a link to the manual, and everything works. It looks like magic, right? I mean, everything's in sync. We're notified if something breaks, and this is super valuable, right? Using Verso, in your doc strings is something powerful, and we hope to see more and more users using this feature from now on. We also wrote a frequently asked questions. We had this page on our websites now. The community is growing. There are many newcomers. There's a lot of misunderstanding. And having a FAQ is a way for us to scale, right? We don't want to keep answering the same questions over and over again on Zulip. If you have suggestions for things for us to include, please send us. The goal is to scale, to not to avoid misinformation. And for example, if someone is making a claim that is incorrect on social media, one easy way to respond, instead of spending several minutes writing a response, just send a link to the FAQ, right? Oh, I want to focus a little bit on growth. Uh, we have many really good numbers, like number of repositories. We're reaching 8,000 repositories on GitHub, 900 just in the last quarter. And we're seeing this kind of super linear growth in many different areas. Another example is the number of unique installations, right? As I said, it's more than 90,000 since the beginning of 2024. And we're really excited about that. These just unique installations, the information provided by the Visual Studio Code marketplace. Of course, this is not counting people that download from GitHub the VS Code plugin for Lean. Only people that are downloading from the Visual Studio Code marketplace. Lean is now being used in several big tech companies, AI startups, academia. We're really, really pleased. And this is a sign of a healthy ecosystem, right? And another thing that will really surprise us, positively surprise us, that Lean is the only proof of system appearing in a respectable position of this ranking of programming languages by RedMonk, right? And if you look at this graph, you are in the neighborhoods of systems like Mathematica, Smalltalk, right? Emacs Lisp, right? Oops, sorry. We're in the same neighborhoods. The only other proof assistant that shows up in this graph is Coq, and is on the bottom. It's here. I mean, they put this other system on top of Coq, but Coq is here on the bottom, right? There's no other proof of system. Only Coq and Lean appears on the ranking by RedMonk. It's also impossible to not mention AI, right? I mean, and I think this paper summarizes many things that happened in 2025, right? Now we're seeing a paper where people are solving an open conjecture by vibe proving, right? It's like vibe coding, but proving using ChatGPT and Lean together, right? And some people claim that the solution was in the literature, but people were not aware, right? The AI was capable of finding the solution lost somewhere on the web, in the web, right? And causing a formal proof for it, right? It is a big deal. And it didn't stop there. The AIs by many of these startups, like by Axiom Logical Intelligence, Axiom Math, they all start proving open conjectures by others, right, in the last few months, right? Something that would not believe to be possible a few years ago. I found funny last month, someone posted, "Oh, we solved this other's problem." And someone replies on social media saying, "Oh, it's not a big deal. This is just like an IMO problem." Well, I mean, 2019, when I don't know I think many of you were there when Daniel Selson proposed the IMO Grand Challenge in 2019. And everybody said this was impossible. No way AI would solve IMO problem. And now people take for granted that AI can do it, and they say this is an easy problem, right? It's like IMO problem. But it's a good sign. I mean, things that people thought were impossible a few years ago, now people think they are easy, and this is a trivial problem for AI. And I find it really remarkable. We are very happy with all the startups. I think these are the five main ones we are aware. If you're missing your startup, please tell us. We know there are many more. I mean, some of the venture capitalists that are funding these startups told us there are more than 20 that contact just these venture capitalists. And it's great to have a thriving startup ecosystem. Right? It validates Lean as a platform of choice for verified AI reasoning. And this is unstoppable, right? I mean, many of us are already using AI. Kim convinced me that AI is really powerful for developments and for generating tests, documenting your code, reviewing. I mean, AI found bugs in our codes and fixed the codes. I find it now mind blowing. And this is just the beginning. You have to keep in mind this is all going to keep better and better. With tooling on top of these AIs, that this is going to keep getting better and better, right? CSLib, right, is another big deal. Fabricio is going to tell you more about CSLib tomorrow. This is a focused effort for formalizing computer science in Lean. Uh, we should view CSLib as MathLib for computer science. It's supported by AWS, Google DeepMind, SGU, and CentaWare at Stanford. The goal there is to formalize CS foundations, add support for reasoning about codes, to have a repository of verified codes where you have many algorithms and data structures that are common in the literature, formalize it in Lean, and of course, be a platform for AI, right? We believe that the same way we are seeing math of AI thriving because MathLib exists. AI for computer science and software verification will thrive if there is a library like CSLib. And we want to support all these different verification tools building on top of Lean, right? We have Velvet. When I saw the demo, I saw the demo last summer. I was blown away. I mean, when they demo it to me at PLGI, it looks great. I mean, it's a GSL inside of Lean. You can write verification condition, verify, put annotations in your code and gets verification conditions extracted automatically. It, it's really impressive. We have now MVC Gen, the monadic verification framework being developed as the Lean Flow that Sebastian Graf will tell you more tomorrow. There is Aeneas for Rust verification, right? We have Strata, all these different frameworks, right? We at the Flow, we want to ensure they all scale, they all perform really well, and we will keep developing the foundations to ensure that this kind of project performs really well in the Lean framework, right? And AI systems excel at generating codes. They do it really well, but can you trust the code? By Lean's providing the missing piece, right? A proof that the code is correct, a proof that your code satisfies your specification. Well, we have to talk about soundness, right? Because of AI, soundness is more important than ever, right? because of AI now, there are many people claiming they solved open conjectures. A few days ago, a person contacted me saying that they did not solve 1 millennium primes. They solved four of them, and they claim they have a proof in link, right, of these theorems. Uh, uh, it's important, right? We have to ensure that nobody will distract the community saying, oh, I have a fake proof of some important conjecture in mathematics, or that they verified a piece of code that's critical, crucial, but they're exploiting something in the system, right? Lean value proposition rests on trust, right? If the kernel has bugs, proofs mean nothing, right? There are many critical use cases. AI math competitions, verifies software, hardware, uh, all these open conjectures that people are claiming results. As the community, right, as the community increases in size, right, the expectations are going to keep increasing too, right? And this is right. We want to have good answers for these questions, right? We are taking this kind of question, how can I trust a link proof, very seriously. At the Leafrow, we want to provide the tools, the infrastructure, the documentation to ensure our users can verify their proofs to their own standards. Right? We have a small trusted kernel, but one kernel is not enough. From the beginning, Lean, the goal of the project is to have multiple kernels. In Lean 3, we had more, but in Lean 4, we have two extra kernels, right? Nanoda implemented in Rust. We have Lean for Lean implemented in Lean itself. And we have the Lean for Checker that's based on the official kernel, but it's independent, right? Lean for Checker ensures that you cannot use the metaprogramming capabilities to exploit the system. We have export formats, right? And we strongly believe that with different languages, different authors, different approaches, is the best way to ensure our results are correct. Right? We also have a new a full chapter in our reference manual, right, talking about how you should approach validating a link proof, the guarantees you get when you're inside of the IDE, when you use link for checker, when you use Nanoda, and so on, right? The different scenarios and what do you get when you verify, you go through each one of these steps. We also released Comparator, right? It's a trustworthy proof judge, right? Comparator is a project developed at the Linfro. The goal is to have a judge, right? Uh, it's useful for competitions where the organizers are going to have, for each problem, they are going to curate a statement of the challenge, right? Same thing for open conjecture, right? You can have conjectures that have been curated by the community, and after you have this reference statement, right, that has been curated by experts, you can use comparator for checking if a proof for this conjecture for this problem is correct or not. Comparator also provides a sandbox execution, has support for Nanoda and the Ling official kernel, and we want to have support for many other kernels, right? As we said, I mean, we strongly believe that having many kernels is the way to go. But how to motivate people to write new kernels, right? Well, the answer is the Lean kernel arena. The arena.leanlang.org is already up. We are going to be posting more about it later on Zulip, right? What are the goals of the arena, right? The arena is It's a gamified competition for kernel implementations. You're going to have a leaderboard there where you're going to rank the kernels, the different kernels by completeness, soundness, performance, days since last soundness, lines of code, you name it, right? And you're going to have both positive tests, like you have to be able to type check mathlib. And it's really cool. Nanoda, for example, can verify, retype check mathlib. I bet you don't know how fast it is. With a few cores, you can do in 5 minutes. The whole mathlib you can retype check using Nanoda, right? And this is also a way, these websites are a way to tell the community these other kernels exist, how fast they are. It's not more speculation saying, oh, I think another is fast. You can go to the link kernel arena and see the actual number. How long does it take? You say, will increase awareness. People will learn about new kernels or kernels that existed and only the experts knew about them. Now you increase transparency. We are also going to collect negative tests. We want people to submit really tricky tests, exploits, and issues to make sure, for example, if some external kernel assumes some crazy lean definition will never happen, like saying, oh, we are going to have only up to 255 constructors, right? You can submit tricky exploits that try to exploit this kind of assumption is not reasonable. So we're going to have a collection of positive and negative tests. We think many people will start building because you have an easy way to test your kernel. People will start developing new kernels, will try to improve the performance, especially for special situations, right? Saying, oh, my kernel can check Netflix 10 times faster. This is valuable, right? And we will also be a platform to try new ideas. Now, someone has a question on how to implement a new kernel. They can easily test on a massive benchmark suite and on also tricky problems, right? Watch out for our announcement on Zulip. The main message here is decentralized trust. You should not trust us ever. You should verify, right? You don't need to trust Linfro. If you want to implement your own kernel, you should. If you want to use many external kernels, we think it's a good idea. There's no single point of failure, right? If one kernel has a bug, other kernels can catch it. The goal is to have different authors using different programming languages, different approaches, right? And the kernel, this kernel arena will provide a common interface, a common place to test all these different kernels, right? The goal is trust in the collective, not in a single implementation, right? Moving forward, right? 2025 was an intense year for everybody working at the flow. 2026 is not going to be different, right? We want to finalize the standards library, right? The compiler, we want the compiler to generate smaller binaries, right? We want to improve its performance, the performance of the generated codes. Benchmarking, right? So we are investing on benchmarking. You probably, many of you are probably not aware that we have a new benchmarking infrastructure called Radar. Is running on Lean, Mathlib. We have performance data for them, and we are going to have many more benchmarks there. CSLib is there too. Uh, for Lake, we are going to deploy the remote cache, right, for Mathlib. With automation, we are going to be working not just on improving grinds, but making things more scalable. Try question mark will become the standard entry points for sledgehammer like tools We want try question mark calling, ASOP, simp, grinds, linha SMT, and so on, right? And it's going to be extensible. You're going to be able to plug in your own tactic to try question mark. Suggestions, I mean, Kim has been working on the suggestion framework. Lean will come with a, a simple but effective way to suggest theorems. But it's going to be extensible too. You're going to be able to connect your favorite AI to suggest theorems. And this is useful for grinds or apply and so on, right? And we also want to deliver counterexample generation. Then Sebastian Graphs work on a new do notation. It will be fully integrated with the verification condition generator. You should expect many improvements on usability. You're going to have the new auto formatter. This is going to be, especially for MathLib, we hope it will accelerate the PR merge process. Nobody will have to discuss, keep enforcing manually coding conventions. They're going to be applied automatically by the auto formatter. We are going to keep improving the home messages, polishing the interface, and we want to have many case studies showing lean performance gains, not just in math, but in software, hardware verification, AI for math and software, and so on, for physics. And we have this new initiative at the Lean Flow, right? Where we want to enable people in the future to write even papers, math papers, using Verso a mixture of Verso and LaTeX, right? We want also this platform to be a platform for games. We want people to be able to create games without knowing anything about web programming, right? They focus only on the contents. We want to be able to, we want to enable our users to deliver courses without relying on live.leanlang.org, right? Because this is not scalable. If there are many users, simultaneous users, it's going to crash our servers. One idea is to have a very easy way for anybody to launch a server, a local server in their departments, without knowing anything about technical details, just starting a Docker container and running a server that they can teach a course with the right version of MathLib they want, everything pre-configured. The students don't have to install anything on their machines. They just use the web interface. And I think it will have a huge impact on education. We are also going to have Verso and Blueprints integrated. So we're going to be able to use Blueprints and Verso together. I think this is also going to be another big deal for the community. Yeah, these are our plans for this new initiative. Software verification, right? This is another area that we're going to see lots of activity, right? Many of these AI startups, they're attacking math as a first, it's like a first mission, right? They want They are startups. They want to make money. They are not like the MathLib Initiative or the Lean Pro. They are non-profits. They are for-profits and they need to generate revenue, right? One way to generate revenue is going after software verification, right? And all these startups are going after that. And we have to make sure Lean is the best platform for verified software, right? That's why we are investing in the new do notation. We are also developing a call by value tactic, counterexample generators, finer grain incrementality and parallelism, and a new framework. The CM is a new framework we're developing at the Flow that will enable the development of verified condition generators. These tools, INEAS, Velvet, MVCGen, Strata, they're all, we can put them in a bag called verified condition generators. They have all share same scalability issues. This new framework is based on feedback provided by the authors of these tools, right? We had a hackathon at the end of 2025, and we got all the feedback we needed to push this new framework and ensure Lean is super efficient for this kind of application. The compiler, we want to focus in 2026 in smaller binaries, in stability. We want the compiler to be super stable, right? We are going to be improving derived instances, right? This deriving clauses we have in Lean, sometimes it generates, they impose a quadratic overheads. If you have a big inductive data type, it is a big deal. And we are fixing that, right? I mean, you already fixed many places, but there are many to come, right? And there will be many new features in the compiler to improve the performance of the code that's generated by Lean. Stability and backward compatibility is also something it's worth investing a few minutes, right? Lean is 12 years old, but Lean 4 is not that old, right? It was released in July of 2023. MathLib was ported to Lean 4 in July of 2023. Uh, it's really made my day because it was the 10th anniversary that Lean was the first commit of Lean that they managed to fully port MathLib. Patrick Massot had a really nice video at the time celebrating that. But what it means that Lean is 2.5 years old, Lean 4, right? Uh, since then, we had 25 releases, right? And shoot more than 7,000 PRs merged in the main repository. Many people complain about backward compatibility. I think they are right. We hear you, and we are taking the actions to improve the current situation, right? When we break backward compatibility, it's not because we want to make the life of our users a nightmare, but some design decisions reveal problems only at scale, right? For example, this quarter, we are fixing a problem that's affecting MathLib deeply, right? We already discussed this problem with Johan last quarter. We promised that we would fix, but it will affect some users. Kim and I are expecting a major battle to fix. I mean, we're going to have to fix this performance issue. Will create problems for MathLib, but we will have to fix them, right? Will be a positive fix, but it's a break of backward compatibility. Sometimes we break because we want to fix a fundamental issue. We don't want to keep accumulating technical debts, right? And the new features like the module system, the type class resolution, there are fixes that we need there too. And the standard library, there are things that in the library were not good. We had to change and broke backward compatibility. But this will keep getting better and better. Our, uh, as I said, we're improving many different places, right? But these fixes are necessary, right? We are building a solid foundation. That's our goal, right? Our commitments, our goal for 2026 is to make sure this is the last year where we have these kinds of breakage, right? From 2026, after 2020, from 2027 and beyond, we want to make sure that this kind of breaking change will not happen anymore. Right now, we are already investing a lot on release notes, documenting all breaking changes. We're taking deprecation annotation seriously. We will invest more effort on migration guides. We understand stability is essential for adoption, and we are working to earn your trust that things will get better and better with time. Looking ahead, we have to keep in mind AI is transforming how it's already transforming how we do mathematics and write software. It's already changed how I write my own software, right? And I think we will have cheaper changes. Right? I became an advocate because of Kim. I mean, but after all the tricks Kim told me, I cannot even imagine developing software without AI anymore. And this will not stop. This is just the beginning. We will have AI systems that can discover and verify mathematics. We will be able to verify software at scale, right? We are building the infrastructure of a trustworthy AI and verified software. Uh, uh, I'm really grateful for all the efforts that we are putting on building MathLib, CSLib, Lean itself, and all the AIs that are benefiting from these different libraries. Please get involved, contribute to new projects, start writing new documentation, lecture notes using Verso, right? Verso is the future for writing lecture notes, games, and in the future, even papers are going to be written using Verso. Report issues, build your own independent kernel, try to participate in the kernel arena. I think it will be fun. Thank you a lot for your attention. Happy to answer questions.